Yes, we can see that. You can
Okay.
tell.
So just to reiterate what's real world evidence, and it's upcoming and why it is so critical in current situation. So we often hear that let's take an example of CAR T therapies. Now these are so upcoming. These are specialized, personalized treatments, especially in the oncology space, and clinical trials do prove that they are effective. But if you look at US also, they are trying to have a policy where they're trying to monitor the patients for a period of 15 years, like a long-term follow-up, to understand what are the effects, side effects, adverse events they are having, any remissions or relapses occurring, to understand are these therapies, how are they affecting in the real world? Because clinical trials will definitely happen in a controlled setting, but we want to understand the broader implications of how they happen in a real world setting. So that's why real world studies are really important. And if we take example of India, if I'm not wrong, India did recently approve a homegrown CAR T product called as NextCar 19. The trials were conducted on 64 patients in India, and it has been approved in India. Similarly, another drug has been recently approved this year in Jan in India for CAR T. So with India also moving forward, we having such a transition in our healthcare system also, we need to ensure that we are also collecting the right data which can help the doctors, the regulators, the policy makers to take informed judgment that how are these drugs acting, are we having the potential benefits that we want to have, or if are going to affect having any side effects. So now if we say that CAR T therapies are definitely like a very critical, a very high level, difficult treatments, you can say, like they did very personalized treatments. But even at real world evidence is also important for simple treatments, like you can say GLP-1 class of drugs. Now these were initially used for diabetes management, and now they are booming in the obesity space. India also recently approved, if I'm not wrong, Vigoy and Monjaro. These are the two drugs which India also approved this year. So now with the growing diabetes burden in India and the obesity rise also in India, it's critical or imperative that we also kind of track down that how are the patients reacting in real world. Are they having any addiction issues? What are the broader implications on their other systems like cardiovascular systems or liver? What sort of functions are affected because of the long-term effects of this drug? So I would like to take a pause here, and if in case anybody is not very aware or much aware of what real world evidence is, then I can answer it before I move on to my next slide.
Divya, can you show this presentation in the presentation mode? Please, just
Yes.
slide mode.
Now is it visible?
Yes, it is visible.
Okay. Okay, I'll just move on, Shweta. So as we said, real world evidence is really important, but that brings us to a next question, that where will we get this data from? The real world data. So, like real and India, definitely we have billions of people, we have millions of records generated every day. They are across private hospitals, public facilities, standalone diagnostic centers, labs, everywhere data is being generated. But the current state in India is far from ideal because we don't have data organized in a structured format. It's not codified. We are not following standard vocabularies to a major extent. Apart from that, we are also not having interoperability where you are able to have data collected across different hospital or healthcare settings for a patient. But we are making progress, but we are still far from ideal state. But even if we have this data, it requires a lot of manual effort to kind of make sense of the data, make that data ready, usable for the analysis. So that's where this is our opinion that technologies like AI, ML, NLP, Gen AI can be helpful to structure this unstructured data, bring it in a form that we can leverage it for generating any insights, so bringing out evidence. And I hope you all also agree with me. Okay. Sai, would you like to continue? So I think I'll let Sai talk about what the different technologies we at HealthArc are using, to make sure that we're able to leverage this unstructured data.
Okay. Okay. Thanks, Divya, for highlighting the challenges we are currently facing with the real world data. So we do know now that the amount of data that is being generated is a lot, but as pointed out, that most of it is in like kind of unstructured form, like it is either handwritten or image-based data. So what we have is a kind of a generic template of activities along with the technologies we use in it to tackle the situation. So first it starts with digitization. The amount of unstructured data is a lot, but the first step to enable its access to the large scheme of data activities before even structuring it is making it machine readable. So OCR is something that is heavily used now, and it has matured significantly over the years, like proven by the results it's being given lately. So we can pass prescriptions, lab reports, discharge summaries, and all sorts of things using it now. Now the next step is, once we have digitized the data, the next question that arises is what's inside it, what's useful. So this is where we kind of go deeper in the usage of AI. NLP, natural language processing, comes into the picture. So since we are kind of in a very foundational stage, like we are kind of consolidating, curating data, to be very literally. So instead of insights, we kind of target the key variables. So it can be the diagnosis, medication, side effects, outcomes, timelines, whatever that is associated with the patient in those unstructured, like it includes kind of the deep parsing of the textual clinical notes, radiology narratives, discharge summaries, and all sort of data we have access to. And once we build a competency on the above activities, next is to refine with for the specificity of the language we are dealing with. For India specific, then for example, we will have to term sugar maybe as diabetes or gas maybe as gastric distress. So that is the what you say next step. So and the third is the final, kind of the most important one. Now even when we have extracted all the information, even when we have extracted all the information, we still face a major challenge, that is the inconsistency. Like one doctor may write HTN in his or her notes, one may write high BP, and we may receive hypertension from one of the sources. So unless we translate everything into a common vocabulary, the data will remain fragmented. So this is where kind of AI enabled mapping tools come into the picture. Like we use tools to map these local clinical terms into standardized vocabularies. It can be your ICD-10, SNOMED, METRA. Then we have our own concept files that we can use to move from vocabulary to vocabulary. But the initial mapping, what you say, AI enabled mapping is what is required to move from that NLP extraction which we have done. And finally, we can transform all this data and model this data into comprehensive data model. It's what that makes this data ready for analytics and research and decision making. So there are many more use cases that can be solved in real world using AI, but this template is to deal with the majority of the foundational use cases that are for consolidating data that we have already have access to but are unable to do any action on it. So moving on, I think we can take a look at some real world examples that we have applied these technologies in our work and the results we have achieved. So these are some sample case studies we have worked upon. So first one is standardizing patient reported outcomes using AI. So in this case study, we were kind of tasked with solving the problem of standardizing unstructured PRO data. So many patients provide feedback through free text responses to the PRO forms, but the data is can be inconsistent and difficult to analyze. So our goal was to uh, turn this free text into standardized and actionable data that could be used for analysis. So in this approach, designed and implemented was a kind of a hybrid approach. It was both a rule-based and machine, like use both rule-based and machine learning techniques. So to start off, we used the rule-based approach where we mapped all the possible variations and checked if they exist, those keywords exist in the data, and use them to categorize. But we were not able to two things, like we were not able to account for all the negation cases. So like no pain was getting characterized as pain. So those kind of cases, and we were missing newer variations that came in as more data got processed, and it was becoming very tedious to keep on updating the keyword list we had as more cases we received. Then next we tried to kind of tackle this. We tried a few NLP libraries, but there also we were missing a lot of variation, particularly due to the nature of the fields we were trying to standardize. Like they were not recognized like proper entities, and that required another kind of a full activity to train the model on those entities. So what we finalized was using a Llama LLM model that we deployed directly on the client system to categorize the ones we were missing. And the final approach, why it was hybrid, was since we were able to categorize around 70% using the keyword process which we had identified. So to reduce the overhead, so just account for 30% of the cases we were missing, we used the llama way to do the categorize missing ones. So the next one is next case study is the generating synthetic patient data for model training. So this is something we do quite often, and we have done across multiple projects. Like we can be creating synthetic data for testing, and here in this case, creating it for development and training of the ML model. So a major, very common theme which we have observed across the projects is that there is data scarcity whenever that data is associated for rare diseases. So our objective here was to create synthetic data sets that closely resembles a real world patient with characteristics, and then thereby enabling model training and testing even with limited data. So we kind of try to kind of not let the process stop even if we have limited data, but it's a very foremost prerequisite we need. Like there we need some sample patient records. So we will kind of de-identify or anonymize them, and then those sample de-identified records are then prompted to the model to generate more such profiles, and the reproduction of those profiles is done by understanding the underlying patterns of the disease progression, patient demographics, and interlinked treatment responses. Once these profiles are generated, then these profiles are then used to train the machine learning models, helping us overcome the issue that we have of limited training data for the rare conditions. There are also alternative approaches we take based on different scenarios, like moving a bit away from pure healthcare data. We have also helped generate a kind of large quantity of conversational data by developing a bot farm, by modeling different people personas in different bots and developing different scenarios, and then capturing the conversations between the bots based on those scenarios. So it's kind of a activity we tune based on the scenario we are dealing with for generating synthetic data. And final cases is like extracting insights from the radiology reports. It's a project I think Divya has worked very extensively in, so I think she can take ahead and explain us. Meanwhile, are there any questions? If anyone has, I can address them.
Hi, can you hear me?
Yeah, I can.
Yeah. So very interesting approach. The synthetic patient data that you are creating for model training, is it in
Yes.
FHIR format, Saivignesh?
Yes, it's fine for me.
FHIR,
So,
FHIR, yeah, FHIR R4?
so no, it
Not yet.
like, but it's kind of mainly for training only. So those standards like HL7 and FIR are like kind of uncharted for, but it's something we can work on. But the cases we have worked on have didn't involve fire.
Okay, thank you.
Yes, Deepak.
Thank you very much. Really interesting presentation from two of you. I know you're still in the middle of the presentation, but I wanted to ask a question about the free text extraction. You clearly had to do this in order to have the raw data in a computable form that you could then use partially for initial machine learning and partially as a synthetic data training set. Once you've got a final algorithm and you have a methodology for the client to in future be able to identify relevant patients, will they also need to undertake text extraction from the clinical records that they're analyzing to run the algorithm? Is that a prerequisite for successful use of your solution?
Yes, so I'll take it, and in case I'm falling short of answer, you can back me up. So Dr. Deepak,
Sure.
I'll just kind of elaborate on the third case study, which is similar to what you're asking. So I'll explain the case study, and if it still doesn't answer your question, then maybe we can discuss and brainstorm. So this was a project where the client wanted to identify a group of patients, a specific group of heart failure patients who had a severe disease progression of having obstructive coronary artery disease of beyond 70 to 75%, let's say. They had severe disease progression. But to identify this group of patients from just structured EHR records was really difficult. Like, if you are just to, kind of tell, obstructive CAD as a term itself does not have a ICD code. Like it does not have a proper coding. You'll have to have multiple observations, multiple doctor notes to look at. You'll have to look at radiology reports to understand that what level of obstruction does the patient have in the major vessels of heart. And it's not just one clinical parameter which the clinicians will consider when trying to categorize a patient as a patient who is requiring a treatment for this specific height, a severe progression disease. So we interacted with multiple clinicians to understand, okay, what are the parameters that you are considering when classifying a patient, that yes, this patient is very risky patient and he will not respond to a normal angiography, or he needs better treatment, advanced treatment, which the client was offering. So we had to find a couple of parameters. So I'll just list 2 or 3 of the parameters of the 6 we discussed with the client. One was LVF, like the pumping volume that a heart will eject every beat. So this volume is not easily available in any report, like just a value. You have to read through the free text report of the radiology report. You have to look at the doctor's notes to understand what this value is, and not something you can get as is for an analysis. So then we built a rule-based logic to identify different keywords of how we could tell what a LVF is, the different formats of LVF, the different reports in which we can go. We went to multiple hospitals to understand that, because every hospital had a different way of telling that same number. Is it 40%?
Absolutely.
So there were different
Yes.
variations to it. Some would say low, some would say 45, some would say 0.4. So different variations were there. So we had a rule-based logic that, the logic would run to the reports and the de-identified reports and say that, if you find any of these value along with this keyword, please extract it. So eventually we started extracting a lot of information from these reports. But the journey doesn't stop there. We also wanted to look at other clinical parameters. It's not just one factor which decides the patient is severe or not. We had to look at the obstruction each blood vessel was having. Some clinicians would just prioritize the major arteries of the heart who would require, some treatment. They would not go for an obstruction of 30% in a minor blood vessel. So they wanted to look at very severe cases. So then we also developed another logic, inferential logic, to say, okay, if you find this is the percentage of obstruction, if you find this is the percentage of obstruction in this particular blood vessel, and that too in this region of the artery, be it distal, middle, there are different nuances there. Then you call it, yes, this is a potential obstructive disease. Similarly, we also wanted to understand that does the patient have valvular heart diseases? The valve heart functions is not proper. And if it is grade 3 or beyond that, then we had to exclude those patients. So we wrote different logics. So once we had all the clinical parameters extracted from this unstructured data, it was converted to a structured table. And then a logic was built on that, okay, when you now next time run through a patient record of any radiology report or clinical database, whatever we had, can you find out which are the patients who fit all these criteria? But the problem doesn't stop there. Every hospital, every doctor has a different opinion. The decision supporters varies. So then we had to validate with multiple doctors, 2 or 3 of them we went to, because everybody had a different opinion. They would say, I would not, there were combination combinations. So each time we went to a different hospital, we had to tweak the model. It can't be used as is for every hospital, because they had the different logic which they wanted. But that logic is something you can have like technically, I don't know what the term is. If you can tell, we have like a code mail logic which says, okay, if this hospital does not want this, we'll exclude it, and we'll have a different input into that. Inputs were changed basically for each hospital if they wanted, but the body of the logic remained the same. And even after
Very
that,
impressive.
and even after that, it happened at times that we were not getting like the time frame. Doctors wanted, I want in the last 3 years only. I don't want a patient who has undergone a bypass graft. So then we had to start filtering those keywords, which would mean a patient has undergone a graft. We need to exclude those patients, or understand if they have any other medical conditions which contraindicates them. So it's like a big process that happens iteratively with clinicians, and it takes a lot of time. We're still in the process, but we thought we could tell people that yes, we can leverage technology to extract insights, give meaning to it.
Excellent. If you write this up as an academic paper at some point, if that's permitted by the client, please make sure that the complexities you've just described are included, because I think there is still, I think the clinical world knows it's a bit messy and inconsistent, but the data science world often gets caught by surprise when it discovers the complexity and the variability, data variability, clinical practice variability, decision-making variability that you've described. And I think it's very healthy if that can be included. So if you do get to write a paper on this work, please do include this learning, very important. And your approach, which sounds incredibly robust as a way of trying to cope with multidimensional variability.
Sure, definitely we'll take
Thank
your
you.
input. And now the next phase is, as Sai was mentioning, we are trying to see, if we can have some inbuilt models get trained on it, but we are still in progress.
Mhm. Well,
Okay.
thank you. Sorry for taking so long. Yeah.
No worries. Anybody else? Otherwise, I'll move on to the next slide. Okay. So this is just like the final slide conclusion, as to what we think from our perspective is the way forward for India to be able to develop a scalable RW ecosystem, a robust system. So we could have two parts to it. First could be a top-down approach, having a long-term strategy of building the right infrastructure. I know right now we don't have all the infra in place, all the resources in place, but instead of waiting for the right opportunity to come, we can always have we can always learn from technology, leverage that, and create whatever we can, make best of what we have. So at a national level, we are having policies, the Ayushman Bharat Digital Mission, where we are having unified system to maintain longitudinal records of patient. It's in progress. We are taking step there as well. Similarly, EHR adoption. Although there's limited adoption of EHR in India, it's restricted to private players. But I have looked at some paper. There are studies which say there's 35% penetration in the market, and there's still more to happen. So it just needs to, increase the adoption at the tier 2, tier 3 city level as well. That would, have much better changes. Apart from that, having global use of, vocabularies being used. So at least personally, I have been to 2, 3 hospitals in Mumbai which are using ICD vocabulary, and there must be many more like that. So we are making some progress there as well. We have disease registries in India. The cancer registry program is there, but we need to have more concentrated efforts towards other conditions like chronic diseases or diabetes or rare diseases, which have certain value when you kind of want to do real world evidence for future. And lastly, to ensure that all these things happen, we need to have the right policies, frameworks, governance, incentives, so that the hospitals are, are encouraged to adopt these health standards. They are able to share the research grade data, maintain it. Sorry, anybody was telling anything? Okay. And just to complement this, a bottoms up approach, this is nothing but we just explain now that whatever data we have, we can make use of the technology that we have to extract information from it, and ensure that we're able to generate evidence at least for the current present. Yeah, so I think that's my like these are our point of view. And if you are interested to know more about AI, NLP, automation stuff, so as a company Health Up, we have a real world evidence conference coming up on 9th, 10th, and 11th September. You can sign up on the website for the conference, and we have a lot of topics around real world evidence, how AI can be used for clinical development, or how LLMs can be used for medical writing, or how we can have automation included in the clinical trials. So a lot of discussions where we have a lot of international speakers coming up to discuss this. So if anybody is interested to know more about AI automation, please sign up for the conference, which is upcoming on 9th, 10th, 11th at HealthArc. I think, Shweta, that is what we had a short, a short, quick of knowledge session, that whatever we wanted to share with people, the work we have been doing. And I think it's open. If anybody want to discuss this more topic with us, they might have also some similar tasks. We can also learn from them.
Yeah. Any questions or discussion points, please raise your hand.
Sure, Paul, I'll send it to you.
Can you hear me?
Yeah, we can hear you.
Oh, hi. Hi, Shweta, and hi, Divya, everyone. I have a quick question regarding what Saivignesh has shown, the 3 case studies. The first one about PROs, patient-reported outcomes. I mean, most of them have, I'm not sure in India how they are using it, but typically they have a survey instrument which is coded and goes by, a name and title and a code. Of course, Loink has its codes, and I think SNOMED also have similar codes for each of the question and the responses. So have you used any such, or in India it's again very custom built one for your research?
Yeah, so for the case we worked on, like there were fields that were configured with these codes, but where the issue was arising, like in the design phase, I think for few of the fields, like there was like no such coding enabled for the survey forms. So there, the responses which the client was like getting in the PROs was very generic, very subjective. That's why there was a need to kind of deploy this what is it, GenAI based solution to standardize the forms or like the values into kind of a list of LOVs that the client wanted. But we can say like like that was not a kind of well drafted PRO survey form. That's why we had those issues and had to tackle it this way.
Okay, so can I ask you a next question on that? So how did you
Yeah.
standardize before you kind of generated how did you standardize, or what did you map against if it is if
So
the origin? Mhm.
So as I said, like the case study itself, like the first approach was like mapping with the like we were going manually, like we were mapping with the list of values we had and tried to map it the keyword list for each field. We had a list of mappings we had to, and we made one-to-one mappings for all the values we were getting. But then as more data got processed, like we were observing more variations in the forms. There we tried to kind of use NLP because it's kind of a data that was leveraged from a chain. Like there were 2 3 sites that collated the data. So at the end we had to use this kind of a llama based approach where we kind of fine tuned it a bit, but it was able to account for the cases we were not able to standardize.
Okay, and you also talked about diagnosis. You were, because I know in India it's mainly ICD, but have you used any other coding systems like SNOMED or Nanda or any others?
So for India, Divya, you want to answer? Like because
At least
in
in
my
India, we have ICD, but for our client projects, we have used Nomad.
yes.
No, because you said you talked about coronary heart disease, and also I don't think ICD the diagnosis in the
Yes,
case level would suffice to go into the nitty-gritties of the CAD diseases and all the various
yes, yes.
parameters you talked about.
Yeah.
So yeah, that's where my question was. Okay,
Paul, you have
so
a
that's all
question?
from me. Thanks.
Yes, fascinating presentations. I would like to hear from the authors. How do you see the future of this kind of work in India? Are we going to see a boom of these, or is going to be skepticism on the black box problems we have with LLMs?
So Divya, you want to answer the first part, the LLM part? I will take. Like that.
Definitely, this will be taken positively in India. This is my opinion, and this comes from a really personal experience. When I've been to multiple hospitals, I've seen where my records are getting stored, and I would like to take a look at them. That okay, with this hospital, this is what my HB level was, or this is the current HB when AC level happening. So at least from a patient level, yes. My family feel that yes, having some records, having some structured data to ourselves will be useful. So same thing doctors will also want. They would want to analyze the data, so I think it will be very useful for them. And regarding Gen AI, I would like to answer. And I think I would let the doctors also answer here because we as consultants are working on these topics. They might have a different opinion.
For the Gen AI part, most of the clients we start to work with, and when we have kind of explain our approach, like they are very skeptical whenever we like kind of bring in LLM models, and they say like, where the data will go, you are making API calls and those things. So for the first part, like it depends on the use cases. Like if we are generating something synthetic, like there are no compliance like implications, like okay, GDPR. That those things we have a preference to open AI models. But whenever like we deal with patient synthetic data or anything, we try to use this client deployed models like Llama, that is primarily locally deployed LLM model, or we try to create a self-trained model leveraging NLP libraries we have. So we ensure like that a black box is maintained kind of to ensure this the patient data stays in the same ecosystem.
Thank you.
Karthik,
I,
would like to? Yeah.
yeah, I have a question you mentioning LLM, Gen AI, you're applying Gen AI for your analytics. Have you tried being in India, we have to handle multiple regional languages and stuff like that. Have you used your LLMs to tackle that language issue?
So Hindi it's able to actually. So we have tried with not for kind of healthcare data, but for like we do support other domain projects also in tech. So where we had a kind of for a ed tech company, we had a kind of solutions that were kind of transcript from Hindi to English, then to the common doubts repository, so that it is able to handle very quite well.
Okay. Did you handle any of the speech to text kind of a thing?
Yeah, that we have done. Like we have also kind of done some. I can share further details if you are interested. But we have done a kind of project on kind of thyroid detection using speech. So that kind of changes like the data is kind of transmitted into machine readable embeddings, and then that the ML pipeline is started from that.
Okay. Okay. One reason I asked is like this, especially we do not have for regional languages. There is not a comprehensive speech libraries are available. So I was just curious. Did you use any speech library for different dialects for Indian regional languages?
No, apart from Hindi, no other
Okay.
ones. Yeah.
Okay. Thank you.
Any other questions?
For the NAR, for the named entity recognition, have you guys tried UMLS by any chance?
For one of the project, so we don't have the kind of a direct license for it, but for one of the clients, it provided us with the license, and we did give it a try. So still, like,
UMLS is free license, right? You can get,
Yes.
from what I know.
okay,
Yeah,
Yeah,
so
it's
it's
I'm
a
free.
not
free
sure.
Actually, you
license.
just have to. Yeah, it's a free
Right.
one. You have
Okay.
to just register and you can get it.
Okay, so maybe we didn't have an account, so we were using a client account for it. So I was not
Okay.
sure.
I
So,
just wanted
but
to let you guys know. It's very useful.
Yes,
And
yes.
you have the browser and you have a local downloadable version called Metamorphosis. And you can choose the code lists you want. It has some 250 code lists, but you can pick and choose the ones you need, and you can just download. And then, yeah, after that, you know what to do. Yeah.
Thank you.
Yes, Sudha. Okay, there are no questions. I think it's time to leave. Thank you. Thanks for joining. Thank you all. Thanks for having a good discussion here. Maybe next community call, we will meet up with a new topic.
Thank you.
Thanks. Bye-bye.
Bye-bye.
Thank you. Bye-bye.
Bye.
Have a nice
Bye.
evening.
Thank you.
Bye,
Bye.
everyone.
Thank you, everyone.